Recording in progress.
Perfect. Okay, so to do number one, the best thing to do is to know the 36-90 ratio as well as the 45-45-90 ratio. Yes, it's a bit of memorization, but you can actually derive it if you kind of forget or if you just freeze up on a test or a quiz. For example, for 30, 60, 90, if this is 30 degrees and that's 60 degrees, think about where that came from. That came from an equilateral triangle, right? Equilateral triangle, all the angles are 60 degrees. Say, for example, each side is 2. Then, of course, that's 1 and 1 because that gets split in half. And that's root 3 because of Pythagorean theorem. So you could totally derive it if you forget. And you know that's 60. You know it's 30. Sorry, messy handwriting there. So that's 1, that's 2, and that's root 3. And it doesn't have to be that exactly. I mean, it's just a ratio, right? So for sine 30 degrees, that's 1/2. Oh, meant to switch colors. My bad. There you go. For sine 30 degrees, that's 1/2. For cosine, it's root 3 over 2. And for tangent, that's 1 over root 3. I don't care if you rationalize the bottom or not. I just cannot do 3s for life from here. Oh, goodness. There we go. 30 times charm. Okay. I don't care if you rationalize the bottom, but it's good to know that 1 over root 3 can be expressed like this as well. That's yet another way you could express it when you rationalize the denominator, meaning make the bottom 0. Sorry. Remove the radical from the bottom. So I meant to say. For 60 degrees, now you look at the other angle. So the sine will be root 3 over 2. The cosine will be 1/2. And the tangent will be root 3. Or root 3 over 1. I don't care. So whatever you want to do. And then for 45 degrees, again, you could derive it because you know 2 sides are the same if 2 angles are the same. So that's 1 and 1, that'd be root 2. Again, 45 degrees, 45 degrees. So the sine is 1 over root 2. The cosine is also 1 over root 2. And the tangent is 1, right? So those are kind of the basics you really need to know for trig. You really want to know those basics incredibly well. The 1 over root 2 part, if you want to rationalize it, go ahead. Now, for those who are doing SAT or ACT later this semester or next year, sophomores, you might be doing it, right? Sometimes they'll do trig questions and the answers are given like this. So you might be saying, well, I know the answer is this, but why don't I see that? That's because it's expressed this way. So just make sure you know that it can be expressed differently. But for me personally, I don't care if the bottom's a radical. I don't care because the calculus doesn't really matter. So, you know, I'm trying to get ready for the next level. I don't care. Questions on 1? We're okay? All right, great. Now for 2, it's not your typical triangle. I mean, it's not like the ones in red and green. It's just a right triangle that follows Pythagorean theorem. And angle X, of course, is right here. Actually, it's not clear yet because I do want to do a screenshot. Yeah, so angle X is right here. So sine of X is easy. That's 40 over 41. Cos of X is easy. That's 9 over 41, because remember, you're doing the adjacent over hypotenuse. The adjacent's 9, that's right next to X. Of course, 40 is opposite. And tangent is opposite over adjacent, that's 40 over 9. All right, let me take a screenshot here. Great. All right, let's keep moving. Okay, these guys. You're asked to solve all parts. It's going to take a little while, but we do need angle C for each of these cases. Actually, X and Y are 2 angles here, and AC is the side here. Angle C is going to be 39 degrees here, 53 degrees here, and 18 degrees here. X and Y, X and Y, X and Y, and of course, I have X and Y there. Yeah, okay. Let's pull up a calculator. We have no choice but use a calculator. We have to. We have no other way we can do it. So just show you what you do. And let me move it over here. And let's get that dialog box out of the way. So for Y, for example, right? Or say x. For x, what you're going to wind up doing is you're going to say sine of 51 degrees equals 12 over x. Does that make sense, right? Because 12 is the opposite of 51, x is the hypotenuse. To solve for x, you have to multiply both sides by x and then divide both sides by sine 51. So I kind of did two steps into one. And you just work it out. That's all. 12 over sine 51. Oh, make sure you're in, I'm in the wrong mode, guys. We'll talk about radians later in the week, I think. So sorry, I got to repeat that. There you go. I'm glad I did that mistake because you don't want to do that in the real thing. That would really suck. 15.44. Define y. You could do Pythagorean theorem. You could do 12 squared plus y squared equals 15.44 squared. Once all cleaned up, so I'm gonna do that squared minus 12 squared. Yikes! Oh goodness. Let's clear that. Okay, 2. Much better now. And then root it. When you root something, you could raise it to the 0.5 power. It's the same thing. I get 9.72. You guys get that? We're good? No? We got that? Yeah? Good. Okay. So 9.72. And then at this point, I'm just going to go a little faster because in the interest of time. So for this case, I'll say tangent 37 times 25 to get x. So tan 37 times 25 will get me x, because it should be smaller than 25, so 18.84. If I do Pythagorean theorem, I have to square that and add to 25 squared. And then root it. That should be the biggest side because it's hypotenuse. I get 31.30. Swear, I need to get a stylus. 31.30. And then for the next one, again, let's do tangent. I'll do 3 times tan 72. When you get very good, this can move quickly. That should get me y, which is 9.22. Sorry, 9.23. Then let's clear that. Sorry, let's do a Pythagorean theorem. That squared plus 3 squared. Root it. And you should get 9.71. Okay, all is good there. For these problems, you're going to have to do an inverse trig. So I'll need to say this. You could say tangent of y equals 10 out of 18. Does that make sense? So y would be the inverse tan of 10 over 18, or 5/9. If I solve that, it's very busy. My apologies. Inverse tan of 5/9. Yeah, I get 29. We'll say 29 degrees because it's round to the nearest whole number. 29 degrees. That's y. So x then has to be 61 degrees. Do you guys get that? Yeah? Okay, everyone's nodding. That's good. And then AC, just do Pythagorean theorem. And you're going to root that sucker. That'll be a square root of 100 plus 324. Don't do in your head if you can't. 20.59 is that side. Minimize, screenshot. There we go. Okay. For these problems here, you could use a circle if you want to, or look at the notes. Remember, the height is what we're trying to find. So 30 degrees was right here. So you had to go down a certain distance to get there. You should have got 1/2. Actually, let me take it back. That was 100. So it should have been 50. My bad. That should have been 50 feet. You got to climb down 50 feet. For 120, I think that was 85 feet, if I'm not mistaken. For 225, now you're climbing up. So that's going to be a negative value. I think that was negative 70. 270 is way down here. That's negative 100. So again, just using those values, and really just find values, right? You have a hypotenuse of 100. If you have 30 degrees, that's clearly going to be 50. That's clear. That's what you're doing. You're doing 100 times the sine of that value, like sine of 120. If you work that out and do 100 times that. Now you can't draw 120. It's kind of hard to do. But if I do 100 times sine 120, yeah, you go in, it's close. 85 is fine. 86.6 will be a little more precise. But we're going to kind of explore that in more detail later this week, that all that stuff. Yeah, Gus, go ahead.
Well, why is it? It's asking like which C is the same. Right, so like, I just.
Oh, which feet? Oh, got it. Let me answer that question then. Thank you for clarifying that. Same thing would be 150. This would be 60. This would be 315, and there's no other seats. I mean, I guess 90 if you want to say that, but it's going the other direction. I got you. Yeah, but it's kind of unique, the 270 part. Okay, let me do a screenshot there. All right. Let me erase the other one so I don't confuse myself. Documents. I think we're good. Clear. Yeah, we're good. Oh, it always does that. Okay. Then you got just some goodness. Then we just got some old stuff that we have to get through really quickly. Don't want to forget the stuff, right? Even though March 18th, 2 months from now is going to come by pretty fast, and you're going to want to make sure you are ready for finals. We don't want, any surprises. They're like, oh my God, I forgot this. So I want to keep reviewing old stuff. That's the formula, which by the way, I'll give to you guys. I won't expect you guys to memorize it because it's a seldom used formula, but P is the principal. E is just a number. We know what E is. Euler's number is 2.7 something. R is the rate, T is the time, and A is the amount of money you got. So for part B, if you're starting with $2,000 times E 0.08 raised to the 10 power, or sorry, the power is going to be 0.08 raised, so the exponent is 0.08 times 10. Work that out. That's where we need a calculator. $2,000. Second ln is where you can find E. 0.08 times 10. You get 4451.08. 4451.08. That's how much money we got. Okay. And then for part C, to triple the money, you want $6,000, right? That's triple 2,000. E, the rate's still 0.08, that didn't change, but we got to solve for T. Divide by 2,000 to get this. Do you guys remember what to do after this part? How to isolate the exponents? What do you guys do? Yeah, you got to log. Actually, write as log base E of 3, which is the same thing as ln. ln is log base E. If you write base E in the calculator, it's fine. It'll know what to do. So it's natural log of 3 divided by 0.08. And we solve that, whatever that is. Natural log of 3. Close the parentheses, please, because it will follow order of operations. Yeah, so about 13.7 years. That's how long it'll take to triple your money. Actually, I like to do 2 decimal places. It's like 13.73 years. Okay, so that's number 8, that word problem. Don't forget how to do that stuff. Okay, then we have a couple more problems. For 718, I was going to kind of give you the answers, and I'll kind of just briefly explain them. There's a smudge on my screen. That's a 3. Okay, good. And you're going to rewrite like this one here. So why is the first one 0? Because you're going to tend to do 0 prior to 1. These knock each other out. Log base 10 and knock each other out. That's just 3. Log this here, 10 log base 10. The log is the inverse of an exponential function, vice versa. So they knock each other out. Here, roll 3 back, and that's a 64. And then again, you have a log the same base as the exponent, was an hour. Those knock each other out to 64. That's how those turn out. Lastly, for 719, if you factor that, that would be a wise idea. That's x minus 1, x plus 5 over x minus 1. Boom, boom. X plus 5 is what it looks like, but it's not a line, actually. If you do graph it, you'll see a line. So what kind of function does it appear like a line? Why is it not correct to connect all dots? Because there's a hole, we're going to say a hole, at x equals 1. It's undefined there, because you can't divide by 0 in the original equation. And if you were to plug in numbers, like if you plug in -2, I know I get 3, 4, 5, undefined here actually. Plug in 2, you get 7 and 8. And if you plug in these numbers close to, I'm just gonna get my graph calculator. If you plug in numbers, well, actually, I kind of know what's gonna happen. It's gonna be 5.9 and 6.1. Whereas here, 5.99 and 6.01. So it gets close to 6, right? But not exactly. So it gets really close to 6. So the simplified form is just this. Kind of did it for you guys already. And why does it look like that? That's because we canceled out the x minus 1. That's why it looks like that. But it's not true. The graph is going to look like this. Whole and keeps going like that. That's 1 and 6. So, yeah, we're good? Cool. All right, awesome. All right, so let me do a screenshot of that. And I just realized, I don't know if I did a screenshot of the last one. Sorry, I'm just going to. All right, let me do a screenshot of this one also. And do a screenshot of the last one because I don't think I got that one either. Actually, maybe I did. Let's see here. I did. We're good. Okay. Cool. All right. Going to clear all that. Okay, great. So that was a very thorough review of the homework. Hopefully you guys are comfortable now. Let me hand out the new stuff. And the homework's attached to the back. Doesn't look like it has some yellow paper. I didn't care of that. So that's okay. We'll be fine. I'll see if I'm good. Yeah. Yeah.
Thank you.
Yeah.
Told you that.
Everybody. Actually, I don't know. I can't remember.
Thank you.
Yeah, you're welcome. Okay. All right. Let's talk about circles and sign graphs. Okay. Let me just scan the notes really quickly to make sure I know what we're dealing with here. Okay. So this is kind of an extension of what we did on Thursday with that little wheel and the cereal box. So let's start with number 1. Guys, quiet, please. Let's review how to change the window on our calculator to see the sign graph. Okay. So we're going to do that in just a second. But some new vocabulary. We're going to talk about something called a unit circle. That's a circle with a radius of 1 and center of the origin. Periodic function is what we're actually doing. A sign graph is called a periodic function. I'll explain why that it's called a periodic function in just a minute. Period is a one cycle. Like, for example, we have 6-minute periods, right? So that's just like a regular cycle, right? That we notice it has a pattern. And then number 2, how can you graph 2 periods of the sign function on the calculator? Okay, so we're going to do some calculator work right now. Let me pull up the calculator. And let's go to turn it on. So let's make sure we're in degree mode first. Okay. We'll keep it in degrees for now because that's kind of what you guys are comfortable with. I don't want to do radians just yet. We haven't had that discussion yet. I'm just gonna graph sine x. Okay. Now, if I hit graph, because I didn't adjust the window, you're not gonna see much, right? Actually, I can't see much. You see a little line there, but you don't see much. What's the window right now when it's standard? What it goes from what to what for x, guys? Yeah, -10%. How about for y? Negative 10%. Y doesn't matter so much, but I know the highest that sine can be is 1. So we saw that from the streamer, like the highest value we got was 1, the lowest was -1. So I might adjust the Y window also. So let's go over here. Let's go to window. And if you want to do one cycle, let's go from 0 to 360. And let me make each tick mark 30. We'll make it 30. And then for Y, I'll go from -2 to 2. So that's the window I'm going with. Y 0 to 360, guys. Y 2 0 360. How many degrees is the whole circle?
360.
Just like the screamer, right? It went around one time, right? What was that? Yeah, that's okay. That's fine. We're gonna expand it though, and then just a little bit. But if I graph now I see a better curve, right? And this is actually one full cycle. So that's one full cycle. So it looks like this. That's y equals sine x. Where that right there is 360 degrees. That right there is 180. That right there is 90. That right there is 270. And that is at 1. And that is at -1. Okay? So, up, down, down, up. That's how graph looks or something. Looks exactly like that. At 30 degrees, it's kind of hard to tell. But if I do, looks like it's probably 1/2, right? At 30 degrees. So yeah, and it just repeats itself. So what's happening here? You get this. That's like Q1. That's Q2. That's Q3. And that's Q4. And we're going to relate this to a circle in just a little bit. But if we break up the quadrants, 0 to 90 is the first quadrant, 9 to 180 is the second, 180 to 270 the third, and 270 to 360 the fourth. This is one full cycle. Davis, go ahead. Oh, do you didn't get one? Were you in the bathroom? Oh, that's probably what it was. Yeah. Okay. Now, what if I want to do 2 periods? I know it's going to look like this. So one full cycle, that's 1 period. It's kind of like, if you actually had a round clock here, like we go around once, that's 1, 1 period. We have 60 minutes. Same thing here. And I actually did a crap job drawing that. It should be a little more symmetric, but that's okay. Let me erase this part here. So I'll just make a quick adjustment. Just bumped it up to 720. Here we go. So 1, 2 cycles. There you go. So that's how you do the adjustment. Just hit window and choose a max be 720. Yeah, I'll pull up again. That's what we're looking to do. Are you looking for tissues, Davis? Yeah. Do you mind going downstairs and asking Mr. Medina for some? Thanks, appreciate it. All right. Hit window. Yeah, hit window. Yeah, you see max? Yeah, choose 720. Yeah. All right. Let's look at 714. We may not be able to do this one because I didn't prepare yellow paper for you guys. That's okay. Let me just read it, see what we can kind of do a makeshift thing here. Henry and Oliver finally make it home from the amusement park unhurt. That's great. But in need of a shower, fine. As soon as they have cleaned up, they go over to their friend's house to share their experience. On the screamer, they draw a picture of the Ferris wheel and 5 of the seats. Look at 15, 30, 45, 60, 75. See the yellow paper provided to you. Don't worry about that. On the yellow paper, label each triangle with its calculated height using the table function on your calculator. What we'll do is this. I'll do this in the calculator so there's a video of it. You guys can see how it looks. And I'll just draw some triangles down below. And then draw 5 new triangles that are congruent to the first 5, but in the second quadrant, blah, blah, blah. So all you're going to do is this. You're going to hit second window, keep it at 0, but change that to 15. And then hit second graph. And see, it gives you all those heights, right? So again, just to back up a little bit here. Y equals sine x. Hit second window. Table start should be 0. Delta table should be 15. Then hit second graph, pull up the table, and you'll see all these different values. 15.25, 0.5. So on the screamer, I'll kind of draw the cereal box. And you had this, the circle is sticking out, right? So, gosh, it's gonna be really hard to draw these, but that's 15, that's 30, that's 45. I know, so I'm really squeezing this in, aren't I? And 75. So if you think about it, what are the equivalent angles on the other side? The equivalent angles on the other side will be then 105, 120, 135, 150, and 165. These are the same as the other ones in the first quadrant. 75, 60, 45, 30, and 15. So those are all basically equivalent angles in many ways. So the sine, like if I were to keep going for this table here, notice that 105 is the same thing as 15, right? 15, 105. Wait, no, sorry, I meant to say 15, 165. My bad. 15, 165 are the same. But 105 and 75, those are the same. 120, 60, those are the same. 135, 45, those are the same. 30 and 150, those are the same. And if you were to draw those triangles, like for example, 15 degrees, right? If that's 1, actually that was really technically 100 on the screamer, then that was roughly 25, right? Or for like 30 degrees, I'm not gonna draw them all because it just takes too long, but you get the idea, right? 30 degrees, that's 100, that's 50, and so forth. So that's what these represent, the sine values. So y equals height. The whole point of this exercise is the same as sine x. It's the same thing. That's why I say y equals sine x. So we're trying to draw this, make this connection here. Questions so far? No? All right, let's keep moving. So can you just process by drawing the third and fourth quadrants? I'm not going to do it. The one thing is that the sine values will be negative, though, just so you know. But still symmetrical. Still symmetrical. So if I were to go back to the table again, see they're all negative now, right? See how you get net 0.25 for 165, but negative 0.25 for 195. See for 150, you get 0.5, 210, you get negative 0.5. 135, you get 0.7, 210, you get negative, 225, you get negative 0.7, and so forth. And that's why the graph is below the x-axis now, right? So it was above initially, then went below. And that 1A is like right in the middle, right? So that's what's happening. So the relationships you can find among the points in a circle, it's really all about symmetry. That's really the relationship between it. Let's do 733. One sec, while you guys are copying stuff down. Okay. All right, so we've been going clear. So draw a circle below, then draw a triangle that could represent Oliver and Henry's position on the wheel. Choose different angles from any of those you drew in the previous problem, blah, blah, blah. Okay, so let's do this. So this right here, I'm calling a unit circle. I'm going to kind of just get into it with you guys. A unit circle has a center at 0, 0, and radius of 1. And let's say I choose 30 degrees here. Let's say I choose that seat. So that's 1. So if you think about it, how high or how long is the vertical leg? The one opposite 30 degrees, guys. How long would that be if the hypotenuse is 1? Using the ratios that you guys know. It's less than 2. It's got to be less than 1. 1's the biggest side. 0.5, good. 1/2, good. 1/2, right. And by the way, this will be root 3 over 2. If you were to do the 3690 ratio, do Pythagorean theorem. So have I labeled a triangle? Yeah, I have. And measure from 0 degrees, I did. Did any of the rows have to climb the same distance to get? Let's not worry about that question. Let me just cross that off. So the bottom line is that if you think about the coordinates here, what will be the coordinates at that blue dot? Given how the triangle is set up, given that this is root 3 over 2, and given that this is 1/2, what are the coordinates at that blue dot? Yeah. Perfect. Got it. Excellent. That's the unit circle, guys. Because here's the deal. What are going to be the, let me choose a different color. Let's go pink. The top point that's in pink on the y-axis. What are the coordinates of that point at the top of the circle? Given that the radius is 1 and the center is 0, 0. Thank you, guys. Yeah, 0, 1. How about the far left? Where are those coordinates? No, the far left with the pink. -1, 0. How about the bottom, guys? Question, Hunter? Because our radius is 1. We're making the radius 1. That's why.
How far are you from the center? I'm gonna get there.
That's 1, 0.
So this blue dot obviously has an x value less than 1. Y that's 1, 0, 1.
What this tells me is that this right here is a sine of my angle. And this right here is a cosine of my angle. So the x coordinate is always going to be cosine. The y coordinate is always going to be sine. This is true for a unit circle. When you have a unit circle, that is always true. the y coordinate will always be sine, the x coordinate will always be cosine. That's 100% true.
Like the symbol for it.
Yeah, exactly. So for example, if I want to find the sine of 60 degrees, I just look at the y coordinate, or on the screen, or like what's the height that you have to go down. So, and let me show you guys unit circle how it looks in all of its glory. Because we're going to do that probably on Wednesday. I'll go back and put my writings back up again, but this is what we're going to be working our way towards. It's going to be a little daunting at first, but it is incredibly helpful for when it comes to trig. And if you have any siblings that took pre-cal or Algebra 2 trig honors, they'll tell you that's just one of the big things they did. So you see this here?
It looks a little daunting at first. But we call this 0 degrees. And if we go counterclockwise, 30, 45, 60, 90. And look at these coordinates. So move through, you have to travel move through this way, and we'll have up to get that. So the sine of 30 degrees is 1/2. So let's say 30 is 2 adjacent to 5 opposites. And so you can evaluate any trig angle,
given that it's in these increments, using unit circle. Like if I said, find me the sine of 150 degrees, I know it's 1/2 because I'm looking at the y coordinate. Find me the cosine of 150, I know it's negative √2 and so forth. So these are things we work our way towards in this unit. Okay, let's go back to, let me undo my erasings. So that's what's happening here. We're talking about something called a unit circle. And you draw a triangle within it, and that should tell you the lengths of the legs. And the lengths of the legs correspond to the coordinates of the point of that angle, the seat.
right? These people are sitting right here, 30 degrees. How far is this person off the ground? That was 100, and that was 50, obviously. If that's 1, that's 1/2. Then how far are they away from the center? What are the zeros? And those things change
In a periodic fashion as you go around the circle. And once you do a full revolution, you've done one cycle. That's how trig works. I've kind of already answered these questions, so I'm just going to jump to the third page. Okay, the last problem, use the unit circle. There we go. Just talked about it. Can you use that to find, can you use the graph? Yes, you can. So use your graph to find the height of a seat that has rotate 130. Yeah, so all you're going to do is you just do 100 times 930 degrees. That's all. And how can you use symmetry to see what it corresponds to? Well, think about it. I'm going to use a little laser pointer here. Tell me when I've hit, or you'll use the hand. Tell me when I've hit 130. Tell me to stop when you think I've hit 130. Probably there, yeah, probably there. So 130 is probably somewhere over here. How far is 130 from 90? 40. So what would be 40 away in the other direction? 50, there you go. Or 130, because these are each 40 degrees. Or each 50 away from the x-axis. That works too. We call those reference angles, which we'll have a discussion later. Let me work this out. 100 sine 130. Yeah, I get 76.6. If I do 100 times sine 150, sorry, sine 50 degrees, I get the same thing, 76.6. So it's all about symmetry when it comes to this stuff. For each of the following angles, find the height at that angle and find another angle of the same height in the sketch, blah, blah, blah. So, for example, sine 130 and sine 150 are the same. So let's find equivalent angles. So 80 degrees. Would probably be like somewhere like right here. What would be in the same height as 80 degrees? Yeah, 100 degrees, right? Okay, 200. So what's equivalent to 200 in the fourth quadrant? 340, exactly. It's all about symmetry, guys. How far is it from the x-axis?
Or y-axis is 2. Is 200, how far is it away from the x-axis? 20, right? How far is this from, this is 360, right? So take 20 away from 360. It's all about symmetry.
Okay, 310. 310 is probably somewhere over here, right? So what would be equivalent to it in the other quadrant? If this is 270, close. 230, yeah. 230. That's all. To find the height, I mean, obviously you have to do sine 80 degrees times 100, 100 times sine 200 degrees, 100 times sine 310 degrees. I'm not gonna actually do it because I know you guys can punch in the calculator. I'm not worried about that. But remember, 310, 230 are equivalent. 200, 340 are equivalent. 80 and 100 are equivalent in terms of sine. So you look at heights. So if you're on the screamer and you're at 310 degrees,
You have to climb the same height as you would at 230. Does that make sense? If you're on the screamer and it stops at 200, you have to climb the same height as you would at 340. If you're on the screamer and you're at 80 degrees, you have to climb down the same height as you would at 100. So it's symmetry.
so you're climbing down or up the same heights as those equivalent angles. And I think that's pretty much it. I think that's all I want to talk about. So the homework for tonight or due Wednesday, kind of ask you to graph, you can graph in Desmos or graph the calculator, and then label, all those different parts that to talk about. Here, each of the points are a diagram, the writer's position. I need to describe where the writer's located. I'll put the answer up as well so you know what they're looking for. More trig stuff, log stuff, old stuff here. Yeah. So, and then something on system of equations. I'm not sure you have enough room to do on this paper, so you might need to do some separate piece of paper. We got 15 minutes. So if you guys want to get started homework, it's totally fine. Given you have 5 classes today, if you need a little break, that's fine too. We could probably get out about 1 or 2 minutes early to beat the lunch line. I'm pretty hungry myself, so anyway, we'll stop there.